We're going to start a new unit on gases, and you're going to see quite a lot of what you learned in honors will help you in this particular AP chapter. It's going to fit into Big Idea 2, which is indicated on the screen, a little bit from Big Idea 1, but mostly here. And gases has been assessed mostly in a multiple choice fashion. On previous AP exams, you could get part of a Part 2 question as well. So we already indicated that we do remember quite a bit about gases, and just to review a few concepts, in terms of some properties of gases, you know that gases flow readily, and a gas will occupy the entire volume of the container in which they're enclosed. You know that gases can be compressed by pressure. For example, that's how some of the people in nursing homes or anybody in need of oxygen can still be very mobile, in the sense that they can have an oxygen tank that has compressed gas, and there's quite a bit of oxygen in there, enough to maybe last the whole day, so that they don't have to be bedridden. One other term that I do want to make clear, because some of the kids get confused here, is the term vapor. Substances that have low molar masses are typically gases or liquids that can be easily vaporized. And when we think of the term vapor, typically that substance will exist as a liquid or a solid. For example, bromine, under standard conditions, is a liquid. Oopsie.
Dr. Kenneth, did you put the notes in Google Classroom?
No, but they're on Edline. I can throw them in.
It's all good, don't worry.
If I convert them, you lose all the pictures.
I was doing that.
Bromine can readily undergo a change in state, and when bromine is a gas, we refer to it as vapor because it more commonly exists as a liquid. Similarly, iodine has the ability to sublime. It more readily exists as a solid, yet it can generate iodine vapor. And this actually is interesting to watch, because you can start with these purple crystals, and if you have them in a contained vessel, something that's covered, you'll see that the outside, the inside of the container will turn purple as the substance sublimes, and those gas particles move around rapidly. There are many examples of gases. We've got nitrogen gas, oxygen gas, helium, argon, etc. Remember that many of the gases are diatomic. Of the 7 diatomic elements, 5 are gases. The 2 that are not gases would be bromine and iodine. So you should be familiar with your 5 diatomic gases.
If you have liquid nitrogen, it would still be N2, right?
Mm-hmm. So your 5 diatomic gases would be hydrogen, oxygen, nitrogen, chlorine, and fluorine. Bromine and iodine are not commonly gases. All right? The other thing I do want to mention to you is the kinetic molecular theory. And this little video I had inserted, it's not delicious. Maybe we'll take a look at it. Well, it has some technical flaws. But in any event, these are the parts of the kinetic molecular theory. And I'm going to show you this in a slide format, but everything I say is already listed in your notes.
Stratton calls Hurricane Irma 6.
Alrighty, so when you consider the kinetic molecular theory, there's a bunch of postulates, and what you're seeing here, for example, are gas molecules that have the ability to flow freely. They move in a straight line fashion. This is showing, I think it's, what is that showing? What do you think that is? It's something diatomic. I'm not sure what that is. Doesn't really make sense because ice wouldn't look like that. I don't know. Maybe they're showing liquid nitrogen there, I'm not sure. In any event, the first postulate is that the particles are very, very teeny. And so we say that the volume of the particles are essentially negligible, 0. Now we don't say the volume of a gas is 0, but rather the volume of a gas is the volume of the container that the gas is in. Negligible means what? Instead of 0, it means there's really nothing there, okay? And that word has come up in the past and the kids don't know what it means. The particles are in constant motion. They're going to move in a straight line fashion. They will collide with the walls of the container, and the collisions are elastic, so they bounce back. That's like a little bouncy ball, ba-boom, 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 as opposed to a game of football where one kid hits the other and boom, they both just fall down, especially if they have a concussion. They're not getting up, right? That would be inelastic. Let's take a look at movement.
The paths of gas particles are very erratic. Particles continuously change direction and velocity as a result of collisions with other particles and with the walls of the container.
So you can see their straight line fashion motion as well as their elasticity in regard to their collisions. And then the particles don't exert forces on one another, so they don't attract or repel one another. So there's no intermolecular attraction between gas particles under ideal conditions. And we'll come back to that later on. The other postulate is that the average kinetic energy of the particles is directly proportional to the Kelvin temperature of the gas. And where that comes in would be what I've listed here in red. It says if several different gases are present in a sample, let's say you had oxygen gas and neon gas. All of the gases have the same average kinetic energy because they have the same temperature. So even if you have different gases, if they're at the same temperature, they will have the same average kinetic energy. And that comes up sometimes. They'll give you a question. They'll say, which of the following has the greatest average kinetic energy? And they're all at the same temperature, so they all would have the same. So that's where that could arise. And you'll see that in the practice quiz that you already picked up. We're going to take a look at some different variables for gases, many of which are on your shirt, so we can use it. The first variable we're going to consider is pressure. And pressure is equal to force per unit area. And there's several things you want to be comfortable with in an equation. The first is the relationship between variables. If in 100-pound, how much does a kangaroo weigh?
175.
All right, if a baby elephant steps on your foot, it's going to hurt. Decent amount of force, decent amount of pressure. Well, if the daddy elephant steps on your foot, increase force, you're going to get an increase in pressure. So what's the relationship between pressure and force? Is it direct or indirect? Direct. So when you have two variables on opposite sides of the equation and they're both in the numerator or both in the denominator on opposite sides of an equation, they have a direct relationship. As one increases, the other increases. In contrast, if you meet a girl you want to take to your prom, you want to look at what kind of shoes she has. because if she can't dance, you don't want her to have spiky heels. If you compare the area of a flat shoe, so let's say the heel is like that, or let's say is that like that's not a wedgie heel. That's just, this is like,
Like a rectangle.
Just a block.
whatever, a block heel, as opposed to El Spico, whatever.
That looks like a beaker.
She's strong.
Whatever. We've got a cylinder and a cone. Fine. Here's the ice cream. All right. In any event, which has greater area?
That one.
This one or this one? So this has greater area, right?
Why does it go through the object?
The smaller the area, the greater the pressure, because pressure and area are inversely related. And that's why when you go in the snow, if you don't want to sink, you wear snowshoes as opposed to boots, because a snowshoe looks like a big tennis racket and it has a greater area. The greater the area, the smaller the pressure. All right? Inversely related when on opposite sides of an equation, but numerator to denominator. If it's on the same side of the equation and you divide it, they're directly related. If they're on opposite, well, let me show you. So, for example, if you had this formula with pressure and volume, if you multiply two variables on the same side of the equation, they'll be inversely related. Whereas if you divide two variables on the same side of the equation, they'll be directly related. And that will help you in your interpretation when we get there. All right, if you want to measure atmospheric pressure, you're going to use a barometer. Nowadays we have digital barometers, so it's very, very simple. Years ago, we would use Years ago, a barometer looked something like this, where you had some type of bowl of mercury, and you had an upside-down glass tube in it, so like an upside-down test tube. The atmosphere would exert a pressure on the mercury. The mercury would rise up the tube, and the distance it traveled, that is the height, would be your barometric pressure, measured in millimeters of mercury, because your height would be measured in millimeters and you have mercury.
I thought barometers measure humidity. Like what? Don't
They measure pressure.
But like in like some, don't they use it in weather too?
Yes,
A
everything.
humidistat would measure humidity. But the pressure can be, you can determine humidity from pressure.
Okay, that's what I thought.
But when you talk like in terms of the hurricane and they were indicating the pressure, I think the unit of pressure that they used was millibars, wasn't it?
Yeah.
Yeah. That's what the guys on TV said. So a barometer measures atmospheric pressure.
Did they not realize that you could get heavy metal poisoning?
Well, we don't really use those types of barometers anymore because mercury has been shown to be a carcinogen, and that's why we don't use any mercury thermometers in schools anymore. Units of pressure include atmospheres, millimeters of mercury, torrs, pascals, kPa, etc. You don't need to memorize these conversions because they will be provided to you on your formula sheet, which you got in both your summer assignment, and I gave you those purple periodic tables. You will see with the gas, you're going to see a bunch of formulas that some of which should already look familiar to you. They even give you the conversion from degrees Celsius to Kelvin. Just add 273. Keep it simple. They give you these equalities here, so you don't have to memorize them. And they also give you gas constants R, so you don't have to memorize those either. All right? So which gas law is oopsie, which gas law is this one?
Ideal gas.
Ideal gas law. Dalton's law? Yeah. All right, so they look familiar. They shouldn't look like foreign entities. Now, if you want to measure gases that are confined to a container, you would use a manometer. And you've probably used them before because you've probably checked tire pressure either on a bicycle or a car or something like that. Just that little thing you stick on and it tells you what it is. Nowadays you have the fancy schmancy ones like what we blow the little pools up with and like the tubes for the pool, things like that.
Temperature also be measured in pounds per square inch.
Yeah. We're not going to really use pounds per square inch, but very often, especially people who deal with cars and bikes and stuff, will use psi. Yep. Variables we're going to look at this year include moles, abbreviated with an N. Abbreviation for the unit is MOL. Volume, abbreviated with a V. Abbreviation, typically the unit will be liters, sometimes mils. You must know that 1 liter is 1,000 mils. Must know that. Temperature, abbreviated T, measured in Kelvin. Pressure, we already mentioned. We do want to investigate the inverse relationship between pressure and volume. We know that pressure and volume are inversely related. If you get a package and it has bubble wrap, you are going to take that bubble wrap and start to pop the bubbles because it's very fun. You're putting your finger on that bubble and the volume of bubble is decreasing. What's happening to the pressure? It's increasing until finally it pops. If you have a syringe and you put pressure down on that plunger, you're increasing the pressure and the volume is going to decrease inside that syringe. Pressure and volume are inversely related at constant temperature. Let's take a look at these two examples. These are both AP level examples that you can do in your head. Let's take a look. It says a sample of helium occupies 500 mils at 900 torrs, the volume and pressure respectively. The temperature is 25 degrees Celsius. If the sample is transferred to a 1 liter flask at 25 degrees Celsius, so the same temperature, what will the gas pressure be in the flask? Well, let's think about it. What's happening to the volume from 500 mils to a liter? It's increasing. Now be specific. It is doubling. So if the volume doubles, the pressure halves. So what's the pressure? 450 torr. The problem took 30 seconds. And that's how you start to move through this. Look at this one. It says a sample of neon occupies 400 mils at 2 atmospheres of pressure. If we triple the pressure, what happens to the volume? It thirds or it decreases by a factor of 3. So this is how you work through these AP level multiple choice questions very, very quickly. When you take your AP exam in May, you're going to have 60 multiple choice questions. You're only going to have 90 minutes to do it. That's 1.5 minutes per question. So you're going to need to work through these quickly, and these easy peasy ones you've just got to work through, some of them in your head. I wouldn't start listing, oh, V1 is 400 and P1 is 2.00. You can't do all that. You may want to label up here as you go and say, ooh, this is V1, and ooh, this is going to be P1 if that's helpful to you. But you've got to work through these carefully. You must know the inverse relationship between pressure and volume, known as Boyle's law. We'll pick up with Charles' law. This is just a brief introduction to gases. Look through your note packet. You'll be surprised how much you already know. There are a couple questions. Hold on. We've got about 3 minutes till the bell. You're okay.
Would the answer just be 3 increases by a factor of 3?
It depends what they ask for, but in a multiple choice format, that's exactly what they could ask. And based on the fact I wrote it that way, I probably put it in the quiz that way. Other questions? If you borrowed a Chromebook, please return it to its happy home. Please, over the weekend, get a beat on it. You are a little behind period 2. If they ask you about Charles Law, you probably remember anyway, but we'll pick up there next time.